Hi, I'm Chris Lucian, and this is the workshop for Chaos Engineering for the Teams. Hopefully you saw my talk earlier, and it will be a new and interesting look at how you prepare for change in your teams. And I'll go over some of the initial concepts in case you weren't here for that first part of the talk. So, um, what we would like to have is 5 sheets of paper, something to write with, or a drawing tool of your choice. What I'm going to do is, because this talk is pre-recorded, I'm going to put in periods of time where you can work on the workshop exercises yourself as well. But if you don't have time for that, you can just watch me do them at the same time. And so there'll be 5-minute periods. You'll work on the sheet. So here's kind of the breakdown of everything that we're going to be doing. We're going to go over principles of chaos engineering and breaking that down again, similar to the presentation talk, although I'm going to go into a more example-driven than anything else. Then we'll go through and we're going to do a number of brainstorming activities where you write on a sheet of paper, and during those activities I'll have some examples. So once again, I wanted to read from the Principles of Chaos Engineering. Chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. And I wanted to say that, to caveat that with human systems, we also want to pay attention to the fact that this can happen to teams being able to produce code. So software provides value, right, to people, and the result of chaos engineering for the teams is that software engineers provide software, right? And so to disrupt the steady state means something there. So we're going to define the steady state for the measurable output of the system. And so we want to come up with different key metrics that will be related. I love this picture here because this is the new steady state for us being remote, and that was teams together mode. So we're going to talk about hypotheses and the experiment and the control group, and in that basically dividing up and having different systems. And so when a team makes a change, typically these days, because sometimes too many things different can break things, there's usually an experimental group and a control group. So we'll talk a little bit about introducing chaos variables. So if you remember from the earlier presentation, or I'll just kind of review it right now, the chaos variables are this idea that these are things that you can change that may disrupt the steady state. So for example, in a distributed system like Netflix, who kind of are the leaders in chaos engineering, so to speak, they might bring down EC2 instances. Well, we might have another person leave a team or something like that. So the next kind of step is to try to disprove the steady state hypothesis. So given manipulation of the chaos variables, have we been in a situation where changing one thing, say bringing down an EC2 instance or losing a team member, does the steady state stop, right? So one really easy example is if you have a siloed developer and they leave, can your software continue to be built? This picture was from a rock, paper, scissors competition where we were going to get hit with pies if we lost the competition. So we had to prepare to minimize the blast radius and make sure that our clothes didn't get destroyed, because they weren't actually whipped cream pies. Instead, they were shaving cream pies, and so you didn't want to get that on your clothes. It might last a little longer than you might expect. So also automating this. So you may think, okay, well, we're going to automate things around software, and that's great, but what about automating these experiments with people, right? And so the simplest form of automation here is calendar invites to make sure that you change these things or things along those lines, or having an automated system be responsible for your team composition, your security credential management, things along those lines. So I'm going to go through a list of examples, and in these examples we will discuss just different systems to chaos engineer. So this will just be, we're going to target them, and then there'll be a theme kind of going forward through that, where we will talk about each individual system in relationship to the next exercise and the next exercise. So first, we're going to take some technical examples, and then we're going to equate them to maybe different systems. I'll use examples from the Simian Army, which is the Netflix open source chaos engineering toolkit for essentially AWS environments. And then we will also go into, I like this idea of using concepts from machine learning cross-validation to make sure that machine learning models are truly resilient, and then things along those lines. So you can't see the rest of that slide because it's behind my face, but that last one says, can this be simulated by swapping team members long term? So, this is the example I gave earlier. Shut down an EC2 instance in a resilient system. That's what Chaos Monkey does. And then load balancers do health checks to bring them back up. And then this is basically analogous to Office onboarding and offboarding. So the burn CPU is this idea that, or burn IO. These are two Chaos Monkey tools, Simius, Cogitarius, and Occupatus. And so in the Simian Army examples, they either run processes so the CPU is fully allocated, or they run disk operations so the IO ops are fully allocated. This is kind of like a team being thrashed, so basically giving them tasks and then seeing how they work. Kanban pretty much eliminates this, but if you have an environment where you have somebody that can give a task, you can give a task to and see what happens, and you'd be able to see that. Janitor Monkey, so this is the idea of in an automated way review stale documentation, things along those lines. So this is cleaning up EC2 instances is what Janitor Monkey's used for. Conformity Monkey, also Spinnaker. This rotate areas in code, two people's eyes on all code. So again, this is, are we following the rules of the team, those sorts of things. So one option is to see, this is kind of code reviews in general. Basically, if you have a code review happen and lots of changes are being made all the time because of that code review, then Conformity Monkey might be a thing, and you might start pairing or mobbing. Chaos Gorilla, so this is, Chaos Gorilla is a system, again, inside Netflix. I think this is listed under the unreleased tools, but it's the simulation that entire regions go down in AWS, or entire, so Chaos Kong and Chaos Gorilla are two separate tools. One does regions and one does availability zones. And, so that might be entire teams switching tasks. Can they continue on from where they had left off? Dr. Monkey, this again is basically making sure that all the EC2 instances are healthy and configured the same, and not quite like Conformity Monkey, but basically healthy systems. So this might essentially be, in a human context, this might be something like measuring happiness on a regular basis and addressing it. Security Monkey, again, this is, are the good security practices, happening in practice? And so, again, as an example, you might have people that are, you might have passwords written down somewhere on sticky notes in the office or something along those lines. Like if you can obtain a password through either social engineering or regular kind of shenanigans, then you probably want to address those things. And so running experiments can help there as well. I want to say that, basically a lot of this has to do with like safety and feelings of quality. Measuring those things are also really important. Psychological safety is extremely important in these environments, and running experiments like this also will require that. And so say that safety is a prerequisite is a good way to put it. Maintaining interpersonal relationships is also really important, and so we want to make sure that you know, in these experiments that again, things are safe and you can maintain those interpersonal relationships. You also want to make sure that your gen ratio is high. The gen ratio is kind of the number of positive interactions people have with each other versus the number of negative interactions that people have with each other. So this is the first activity, and we'll take 5 minutes to work on it, and then we'll come back here and talk a little bit more about it. So we're going to have you capture examples of your systems and operate on them. First, we're going to start off by identifying the systems that we want. So in the beginning, I told you to have 5 pieces of paper ready. So the pattern that we're going to follow going through this all is hitting each of the 5 pieces. So each paper will contain one experiment, but we're going to keep going back to each of the 5 papers. So first of all, we can kind of think of systems to experiment on. One of the ones that I really like, because there's a lot of lean aspects to it, is just the prioritization aspect. So first one I'm going to make is right here. I'm just going to write at the top of the paper, the system I want to chaos engineer is our prioritization system. And we're going to then just put that page aside, and we'll come back to it in a little bit. Then we're going to talk about technical practices. I think is another one that I wanted to bring up. This one's really important just because of code quality, things like that. So we're going to just throw the name up there at the top as well. And you're going to do this for the 5 of your papers. So I'm just going to keep talking, but I encourage you to go and start this exercise on your own. Basically, you should have 5 sheets with 5 different concepts on them. So technical practices. And you might have these exact same things in your systems that you want to evaluate as well. And so go ahead and keep adding, and we will verify as we go. But you can use mine as well, but you might want to just kind of think of your own too. Interpersonal dependencies. There's another one. So this one might be related to things that might lead to experimenting with siloing, things like that. Information flow is the next one. So this one is the number of hops that it would take for a piece of information to flow from one person to the next. And finally, I'm going to also tackle information retention. So you might want to go ahead and underline each one of those and put them back onto the stack, and then that will get us to have a good way for us to return to these as we go. If it helps you, it might be good to make a little drawing for some of these as we go as well. So for prioritization, for example, you might have like a little whiteboard with a Kanban on it. So might draw that. I don't know if this is how your whiteboards look in your organization, but it feels
pretty accurate to me. And so it might draw that, and then you might have like a to-do and a doing and a done column, and you might have some words at the top, and then little squares to represent cards. We should only have one thing in the doing column, lots of stuff in the done, that sort of thing. Give you a pictorial representation of where you should be. So if you wanted to go through, make some drawings for each one, and if you wanted to, or just write them down, you don't have to rely on artistic skill for any of this. But I will meet you back here when we're ready to go over the next activity. Please enjoy the next few slides.
So welcome back. So the second example is we're gonna talk about finding the steady state for those systems that we talked about earlier. So given that we've reviewed the list of Simian Army tools and things like that, what does steady state look like for the different systems that we might be addressing? In the Netflix analogy, again, we're talking about they're delivering streaming video or things along those lines, and so that's what the steady state is. So developer knowledge, if we the steady state is that the need for the developer knowledge is regular in order to continue producing software. So again, a measurable output metric of this is commits that are meaningful commits to the code, commits and pushes, while different people are around. Developer overtime, so this is kind of like overburdening available resources and reducing your productivity based on how much overtime is there. So that's just a measurable output, right? And the steady state should theoretically be 0 overtime, and then when there's a hypothesis or a chaos variable that's modified in order to create additional overtime, that's kind of what comes out of that. Developer interpersonal relationships. So this is very similar to measuring the gen ratio again. So if you are in a position of leadership or even not, measuring gen ratio might be just keeping track of positive interactions, things like compliments and things like that, and versus negative interactions like arguments and not arguments, but not disagreements, but arguments or heated things. Developer communication, same thing. Over communicating or under communicating can be measurable. A lot of the time it's did we really need all that information, or did we need more information? Some of these can be, the easiest one of these to track is just bug count, right? So steady state bug count should be at 0, and you work from there. Meeting participant composition. So this is another one that's pretty measurable. It's when the number of participants in a meeting is greatly skewed towards a certain group. So a lot of the time, if you have a unequal representation in a meeting, besides like a Scrum meeting, for example, you might have like 1 or 2 product owners in a retrospective with 20 developers or something like that. That could be a large skew. You might want to have 2 developers to 2 product owners to have the equality of perspective. Manual processes. So this is a thing where it's like manual repetitive processes as a measurable output. So you don't want manual processes if at all possible. You want to automate those things and free up your time, and so that's just one where you shouldn't have any repetition in your day, really. Responsibility and attention. So again, these are things that you can kind of evaluate for each of the members of your team, and the steady state should be that these aren't fluctuating, right? They're relatively the same for large periods of time, and again, implementing chaos variables in order to modify that or disprove that hypothesis. Technical practices, so easy ones: code coverage, cyclomatic complexity, You know, a little bit more objective ones are things like dictionary words used in the code. That can be automated, but maybe code cleanliness also is an important one. And so you can measure the steady state by having clean code that's unit tested, for example. Power dynamics. I just really like this because it says delegate on my badge there for a conference that I went to before, and so that's my delegate, my VR headset there. So the power dynamics might be something like just inequality of power, or a good way to put it is you know, information filtering only through leaders versus individual contributors towards two necessary needs. Team prioritization. So again, I mentioned this earlier, but I really like Kanban for this. And so this is an example of, you know, if your team is easily thrashed, then that can be an interruption to steady state. So team prioritization may be a priority is the same until an item, or until it's completed, and then it's moved. So if you're in a waterfall scenario, then that might be a year where your design specifications are the same and no changes can make it in, which is fairly rare. So this is the next bit, so the next activity. And so what I want everybody to do is go ahead and identify a steady state of your system, and we're going to work through an exercise right now where we identify all of the different systems and their relating steady state, and then we'll come back to more examples. Welcome back. We are going to talk now about the steady state for each of these. So you know, there's some virtuous qualities that we want to see in prioritization, for example. So you might have a section here. So this would be kind of labeled the steady state. Might make this longer. So in the steady state, we would expect that if we had good prioritization, then we would not thrash, right? So these kind of should be like should statements. So the team should not thrash is a good statement here, right? Right? So that's a good one for that. I'm going to do kind of the similar thing here. We're going to say for technical practices, the code should be clean and bug-free, right? On here, the person you need should be flexible, or maybe better would be different people should be able to solve multiple problems, or a single problem should be solvable by multiple people. That looks pretty good to me. Information flow. So this might be information should take the smallest path.
And finally, information retention. So this might be information should last as long as needed, but no more. Okay, and so that kind of is our steady state for each of these. So we're going to go ahead and just create some underlines on each of these, and we'll review them as we go backwards. So maybe this one's information should last as long as needed, but no more. This one is information should take the shortest path. For interpersonal dependencies, a single problem should be solvable by multiple people. Technical practices, the code should be clean and bug-free. And steady state, the team should not thrash. And so I don't know if you're familiar with the thrashing definition, but it's basically before something's done, moving on to something else and then coming back and forth and back and forth. So we definitely don't want this in software because there's ramp up time that needs to happen, and so that's why I put that there. But I just wanted to define that in case people did not know. So I will meet you back here after the next set of slides. Please enjoy.
All right, so we're going to do control, experiment, variables, and hypotheses. So again, we're going to definitely talk through this, and again, we're pulling this from the Principles of Chaos Engineering website, and we're converting them into things that are human related, right? To measure the resilience of your team or to act on them. So again, going back to this concept of the developer knowledge dependencies, chaos variables here and can be things like, is it the same person on the team? So if you lose that person, and do you still have the knowledge that you need? And this is just a siloing metric. And for example, this kind of also plays into manual processes and things like that. Developer overtime, again, chaos variables. So if you start dividing your estimates into, if you do estimates, and so does that start increasing the amount of overtime for the team? And so or things like stress or bad news versus good news and things like that. So you can choose to be positive with one team or negative with another and see how the resulting overtime comes out. Developer interpersonal relationships, again, so different ways of communicating. So maybe you have a number of individual solo developers versus a group that mobs, and so what do their interpersonal relationships look like as a loose metric, things along those lines. So that might be a chaos variable, is how closely they work together. Developer communication, again, what does it look like for the communication if everybody is in the meeting? If you have a team of 10 members and maybe you have 2 people go to a meeting versus 10 people go to a meeting, what does the communication look like? Does it slow down? Does it speed up? Are people more informed, less informed? Things along those lines. Can decisions be made quickly based on the information that's available? Meeting participant composition, again, this is chaos variables, so you might turn up or down the number of participants. You might move the location of the meeting. You might make it virtual to see if you can increase attendance, but these are all things that could disrupt the steady state hypothesis and pull out different results. Also format of facilitation, so retrospectives versus just traditional meetings can also be a really important factor. Manual processes, again, so this is one where leaving one out, right? Leaving a person out may cause you to create disruption to manual processes. And so, and again, finding automated ones. And so it's like, oh yeah, we have to go and deploy the database. Okay, well, now we're going to have a different person, a person that's not been on your team deploy the database. Can they do it, right, without asking you for help, right? If it's automated, great. If it's not, oof, that's going to be really hard to accomplish, right? Responsibility, attention. So again, this is going to be the variable here, right? Is or series of variables is the modifying levels of responsibility, levels of necessary attention to detail, things like that. Technical practices, again, so you have the measurable output of 0 bugs, right, for the technical practices and frequent releases. And so, basically increasing or decreasing capacity. This might be solo developers versus pairs versus mobbers, and different communication factors. Like this one's, all of your technical results end up being a combination of a lot of these things. Power dynamics, again, you might experiment with having a hierarchical structure and a flat structure in the same organization, and seeing what the difference is between communication and reporting structure and how things go. And so you can experiment with that, and so the variable there might be, again, the composition or the process for making decisions can be different for different groups of people. Team prioritization, again, this is like kind of a flow diagram, but in the team prioritization, you can definitely make changes of, the variable might be how frequently new top priorities come in, how the team responds to those things. So again, small, thin vertical slices in Kanban really help with that, but if you're in any other environment than that, just changing the frequency at which new tasks come in. So we're going to do another experiment, or another activity, and so what we're going to do is write down your control, your experiment, your variables, and your hypothesis kind of as a function of each other, or a flow chart, if you will. And so we can work together on that and then talk a little bit about it, and we will come right back here in a few minutes.
All right, here we are back. We want to now talk about variables and hypotheses. So the first bit is we're going to talk about a variable and then what it means to have a hypothesis. And then in the next section, we'll have something about disrupting the steady state using a hypothesis. So when we formulate the hypothesis, it should be in the if, then, because format. And first we're going to kind of go through and just talk about the different variables available to us. So first one is going to be the new task frequency. So in prioritization, the number of tasks being generated could cause thrashing or new priorities, right? So this would be new priority churn frequency. So this is variables. Okay, and so this is just one example of a variable that you can have for this topic. It doesn't mean that you have to only have one variable. It's just that when you're doing the experiment, you only want to modify one variable. So you would then do a tree and basically say these are the different variables and these are how I'm going to tackle them. So the next part is going to be one variable is the number of automated tools. That one's pretty straightforward. We're also going to look at the number of hops. So this is the interpersonal dependencies. We said a single problem should be solvable by multiple people. Oh, sorry. This is the interpersonal dependencies, not the number of hops. So this one it would be just individuals that are available, and so the essentially the variable here is available individuals. And then we're going to move on to information flow. So the information should take the shortest path. So this is going to be the number of hops it takes for information to move. Okay, and so this one is basically, it's kind of a telephone game if you're familiar with that, but it's one person has to tell another, the information quality degrades. So we'll talk about that in a little bit. And then finally, information retention. So information should last as long as needed, but no more. So this will be kind of retention time, right? We're gonna manipulate the retention time somehow in an automated way, right? Retention time. Okay, so now we're going to be able to soon move on to the next part. So we're going to underline our variables here, and you'll kind of see that we're kind of getting a checklist here. Again, I would be doing drawings with these just to remember throughout the workshop, but I didn't want to take too much time here with drawing and things like that.
All right, welcome back. So we are going to attempt to disrupt the steady state to disprove the hypothesis. And so this is kind of like manipulating those variables, and so and then the next activity will be around the manipulation of those variables. And so it'll be pretty interesting to see the outcomes and results of that. So in that we have the developer knowledge, and so again dependencies. And so this one, easiest way to disprove this is if you have multiple teams or working on the same product, then you might just swap people on those teams. Can they move forward, and just randomly swap them. And there's bigger versions of this that we'll talk about later, but basically disrupting any silo. I think that there's a lot of people out there that can think of the one person on their team that if you moved them would mess everybody up. Developer overtime, and basically hero developers. So sometimes there's a lot of developers out there that work overtime when it's unnecessary, and there are other kind of results or negative side effects to that. I'd say in both situations, one, I think the steady state is no heroes, and I think the other one is no overtime. The developer interpersonal relationships, so the variables might be, again, different team compositions, also seeking out, through either one-on-ones or anything like that, like just main areas of conflict or low quality interpersonal relationships, and then trying to shift things around to see how the quality of relationships around individuals ends up going up or down. Over and under communication, again, so this one is going to be modifying the containers in which we have communication available. And so you might have it so that you can only have one representative go to a meeting, or two, or the whole team, or similar things. Like if you're doing solo development, then you might try pairing and or mobbing to modify that variable. Meeting participant composition. Again, the variable here is the attendees, but there's also location, there's also time. So modifying, if there are convenient times for people, this is especially important with international teams. then you want to kind of pay attention to those things. And manipulating those variables can also be really important. Manual processes, again, this is given a manual process, swapping people in and out. This is kind of a siloing metric, but there's also other things too. You know, does adding a piece of automation end up making it so that the steady state is maintained, which is the operation is completed without errors? And things along those lines. So you might have documentation is a variable. There's the number of people involved is also a variable. Responsibility and attention. So again, this one's a different one where it's you know, mobbing versus pairing versus individual work. You know, if you're working with 4 people focused on a task, even if you're working on things like email, can be, you know, quite useful as well. And you know, it'll be really important to pay attention to a lot of these variables and manipulating how those things happen. Technical practices, there's a lot that can be manipulated here. You know, you can increase or decrease the number of technical practices that are happening. You can you know, increase or decrease the number of people working on a single task. You can change the feedback ratio. You can change how, when, if you do pull requests or peer reviews, things like that. So there's quite a bit in that. Power dynamics, again, this is kind of when we were cleaning up our office. The power dynamics variables, and again, the disrupting of the steady state can definitely be some things like, as a leader, trying different styles of leadership. So you might, you know, with one team you might have a servant leadership style process, and in another team you might have a more authoritarian process, and you can see the differences there, and how the team is resilient to either mode. Team prioritization, again, this one is going to be, the variables there are different styles of managing the work. It's going to be, again, the frequency at which tasks come in or not, the overall organizational buy-in to how things get prioritized as well, and manipulating variables around that can be really interesting. So here we are we're going to do activity 4, which is kind of like the list of hypotheticals. So in your previous examples, what are the ways to disrupt the steady state? And so, like I said earlier, if you know that one person that if they left, all production would come to a halt, you might suggest that as a specific scenario and play with that idea.
We are going to start working on the disrupting steady state hypothesis. And so the way we do that is using the if, then, because notation. So, but I'm going to kind of do it in a shorthand, but I'll do it here first. So if we change a variable, our variable, then our steady state should not change because and then so in this one our steady state should be because we have a system, because you know our implementation of Kanban is going to Kanban will protect the team from thrashing. Okay, so we're only going to do the because statement for the rest of these, just to save time and work our way through here. So in this one, it'll be, dot, 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 and then because. And so so this one might be we're changing the number of automated tests. We're increasing the number of automated tests, and our steady state should be clean and bug free because because the code is more protected, right? And this is kind of like an inverse hypothesis. This one might not necessarily be deemed totally chaos engineering, but that's okay. At least you're thinking in that direction, right? So this one, interpersonal dependencies, and so we have the available individuals. So we're going to do leave one out cross-validation with each member. So this would be, the steady state should not change. And then in the ellipses here, we're going to say because information is shared properly between team members. Okay. Then we are going to go to the information flow, and so this one's going to be removing hops. So if we add or remove layers in the organization, do the number of hops change, right? So this would be the steady state would not be modified because we have a good communication strategy, right? This one is information retention, and so we are going to remove stale documents, and the steady state will be good because we proactively remove old documentation. Right, something like that. So go ahead and underline those, and then we'll move on to the next one.
Okay, so here's our kind of final example set, and then we'll do our final activity and kind of conclude. But this is the minimizing the blast radius. So what does it look like when you're essentially doing these experiments? How do you prevent moving members between teams from having massive problems with your production environment? And so silos specifically, if you lose a person, so mobbing and pairing can be a really great way of doing this. So if you mob or pair for a while, you will ultimately result in essentially sharing that knowledge. And then when that person leaves, then you can, that would be a way to minimize the blast radius. If you're trying to experiment on your own, then making that person available for questions, and then keeping track of how many questions are asked of that person once the change has been made. Again, developer overtime, minimizing blast radius here, so you just want to make sure that people don't get exhausted and that overtime is not overly done, and so there can be a lot of bad that can come from that. Things along those lines. And so you also want to make sure that things don't get jeopardized when working on the project. Developer interpersonal relationships, again, so you don't want to modify a chaos variable and then have people end up hating each other. And so a lot of this is going to be through trial and error, and then if you get resistance for, basically putting people on teams together, then you kind of find out why. And so this one takes a lot of finesse, and you want to keep things safe while doing it. And so, a lot of retrospective formats can be really helpful here, and advocating for situation, behavior, impact, feedback formats. Developer communication, again, minimizing blast radius. So if you're going to modify the developer communication, then you basically have to have a way for people to tap out of that experiment. And so, if things are going really poorly, then you want to be able to end the experiment early and just call it kind of a failure, and discuss it that way. That'd be really important to do. Meeting participant composition. So again, if you have meetings remotely, then you can definitely pull in people at will, because you can just call them up and make sure people are just available but maybe not present in the meeting. Things like that. Other ways of minimizing that impact is just easy access for questions, encouraging Q&A for people even outside of that meeting. Mobbing, it ends up being really important for things like that. Responsibility and attention, again, minimizing the chaos variable, or the blast radius here, sorry, is going to be basically making information readily available, changing levels of responsibility and attention to detail is going to be really important for, basically you want to make sure that you don't change the variable too much at once. Technical practices, again, in the technical practices space, there's a lot of variables you can change. And so my biggest recommendation here is just change only one thing at a time. And if you're going to try something, start small, and as you modify that variable, you can kind of see those measurable outputs we talked about earlier. And so a lot of these experiments, you want to keep them kind of small, self-contained, and then grow them out. And so, don't start with chaos monkeys, or don't start with chaos Kong, start with chaos monkey, that sort of thing. Power dynamics. So this is the dam right here. I don't think it generates any power, but this is the dam near our office here. Again, minimizing blast radius. So you want to kind of start with willing participants, and you also, in these experiments, you want to make sure that they're kind of outfitted for success. And so, basically making participation optional can be really big. Team prioritization, again, if you need to kind of have like a way to tap out. So you basically say, hey, if the prioritization becomes too hard, or you become too thrashed, kind of given the software development definition of thrashing, then you might let the experimenter know, so that when the experiment's being run, it can be obvious how we need to modify what's going on right now. So now we're going to do an activity where we identify blast radius mitigation factors. So for your specific examples, what you want to do is write down a few ways of how you would prevent things from going crazy, right, and bad things happening. And so... Okay, so here we are, and this is the last one. So we're going to work on minimizing the blast radius for each of these, and then we'll get you back to the conclusion of the presentation. So here we are on prioritization, and so one way to minimize the blast radius is to regularly evaluate for high thrashing, right, and then stopping the experiment. For
really evaluate for high thrashing. Code is more protected. So this one is going to be, we're going to start small. And basically this will mean that we, as we make these changes and the steady state goes forward, we're going to maybe write unit tests in a small set of projects and see what things look like, how it is, or removing unit tests if that's the way that you're chaos engineering. This one, interpersonal dependencies. So again, we're going to start with just 2. So that one's pretty easy to do. In this one, so this one's the information flow. The information path should take the shortest path, number of nodes. Again, we're going to start small. And it might feel like starting small is right for everything, but it actually is different for each one, right? So we're going to archive instead of delete here, which is different than starting small, right? This means that you can basically remove the documentation, but still have it available if somebody realizes like, oh no, I did it wrong. And then this way you can kind of evaluate and see if your steady state hypothesis of the appropriate retention time is actually true. So I'll let you get back to the rest of the presentation, and that was the workshop for designing experiments for chaos engineering.
All right, so here we are. Welcome back, and we are going to kind of run through our conclusion and just wrap it up. So thank you for kind of going through the exercises with me, and if you've just been watching, then I hope this has been really informative for you. We've gone into kind of a very deep level of detail, and so it's important that we keep things working well. Chaos engineering can be applied to teams. So this is kind of the first piece of it is, we want to make sure that our teams can develop code through thick and thin and are resilient to different situations. Onboarding and offboarding is not expensive. Our status quo for the style of development that we're doing is maintainable. Everything along those lines is really important that we continue to make sure that we can prove resiliency. Resilience for a group of developers is good, and so in this, I would just say that when I've seen disrupted teams and I've seen production kind of halt to a crawl. I've seen systems that they develop so many bugs that they can't move forward in development anymore and can't make any new features anymore. All these things are avoidable as long as we prove our resilience in both the interpersonal and the technical sides. Human systems, like technical systems, are inherently uncertain. So this is the idea that you're not going to prove that your system is resilient without running resiliency experiments or chaos engineered experiments. It is easy to think like, oh yeah, we got this person and they're going to be with us until they retire, and then I'll retire, and then I'll not have to do this. But anybody can leave at any time. The economic situation can change, things like that. Safety is an extremely important thing to minimize blast radius. So once again, developing safety with your team, I feel is a prerequisite for any of this. I think that if people were fearful and you started running these experiments, then you'd get a lot of immediate turnover or frequent turnover. And so I think that, please verify that psychological safety is there before moving on to chaos engineered experiments. Freedom to experiment is crucial to success. So this is one more piece where we just need to make sure that that these experiments are also definable by the teams, and so don't just use your experiments, but also go to the teams, do these exercises with them that I just proposed here, and you'd be able to identify good ways of accomplishing these things as well. Having a good feeling is not good enough. So this kind of goes back to just, the gut feeling versus the actual experimentation. So once again, there's no way to prove resiliency here. You're just going to have to you know operate and and run these experiments, modify those chaos variables, make sure that the system is resilient to it. You know, these things that you'll try should be a minor annoyance to the team, not a disrupting situation. Building software is inherently about communication, so a lot of it is going to be focused on communication, disrupting communication, modifying communication, creating different paths for communication. And some of these experiments can be really simple, just like saying, hey, take that person that's a massive silo, move them to a place where they can't be a silo, but make them easily accessible for questions, and then watch the questions gradually reduce over time, that sort of thing. Feedback systems are extremely important. So this is a pile of retrospectives from the office. So you know, just make sure that you're doing regular retrospectives. There are good ways to do these remotely or in person. And so you know, I highly recommend just checking out things like the Agile Retrospectives book, or even Liberating Structures books for ideas around how to get feedback from your team and feed it back in. Modeling team resilience will translate to team resilience. So again, a lot of this is going to be putting in systems, you know, preferably automated or on calendars that basically, you know, either redefine team compositions or things along those lines. They can be really powerful. And doing these things on a regular basis, running these experiments on a regular basis, will make sure that we don't get to a situation where complacency is kind of taken over. So I just wanted to close it out here. Thank you very much for joining me for this workshop, and I know that we have a live Q&A session after this. My name is Chris Lucian. You can find me on Twitter at Christoph Lucian. My website is chrislucian.com, and we have a YouTube broadcast and podcast called The Mob Mentality Show, which is primarily focused on mob programming, but also hits a lot of other topics like psychological safety, and Kanban and Lean and things like that. So thank you for joining me, and I hope to see you at an event sometime. I'm sorry that I couldn't be there with you this time around, but maybe another year I will be there in person. So bye everybody. Have a great conference. All right, any questions? Hello everyone, I don't know if anybody can hear me or not.
Alan?
Cool. Yeah, so I don't know if anybody's been following the chat, but there were a couple of questions that already kind of went by, and I kind of answered in chat. So one was around essentially different people and the composition of people on a team. And so in regards to chaos engineering, I like to keep things random, because you might get those different combinations of people at the same time, and people with conflicting viewpoints can learn a lot from each other, as long as it can be constructive and forward moving. And so that discussion happened in the chat, and then I talked a little bit about we have rules around any one person can only stay on a team for 2 years out of the last 3 years. They can't stay on it any longer. So kind of has a forced rotating factor, and also kind of prevents that, you know, the ivory tower sort of hoarding of knowledge sort of stuff, and improves the resiliency. And then there's another question around the metrics. I'm trying to find that question, that specific question. And here it is. Do you think hybrid work model? So this one was about remote. And so and whether or not it would disrupt the steady state. And so I'm saying, like, us being forced to go remote has caused us to be in a situation where it's kind of like a forced chaos experiment. And if our teams were already resilient to this, then they would have come out resilient. Otherwise, you know, it's a good wake up call for some of that stuff. And
Okay. And so apparently I am the host, so I can even share slides and stuff like that if you wanted to go back to a specific slide. Let me see. Yeah, I could share the screen. Okay. Yeah, so I can go over any other questions that there might be. I don't know if anybody had done the workshop activities, but I'd love to hear from the audience if you had followed along and done your own chaos experiment design, and if you could share it with the group, that'd be fantastic. If you're able to, just let me know, I guess, in the chat, and I could call on you if you wanted to talk about it. So I'll give it a few seconds here. Yeah, some of the, in one of my questions, I talked about like metrics that you'd want to maintain steady state for. So I'd highly recommend against using software estimates as your steady state. But like meeting of estimates, you'd much more want to track outcome-based metrics like cycle time. Product owner happiness is like a rough one, but things like cycle time and bug count. So if your bugs are greater than 0, getting them to the lowest number possible. If they are at 0 known bugs in production, then getting to the point where bug frequency is low to non-existent, and so things like that. And then eventually, if you achieve that, then it would be something like complexity metrics or file size metrics, things like that. But tangible things that come out of the other side rather than worrying about burn down rate and things like that. Yeah. I'm just browsing through the chat to see what other insights we might extract. I didn't see any questions in the Slack channel. I just see them in the chat here. Okay, we have a lot of time for Q&A. So, did anyone do the exercise? All right. Okay, well, I'll keep hanging out for questions, and please use the chat if you would like to, but I don't necessarily think that there's anything left to cover if there are no questions. Thank you very much, everybody. Have a great day.
Thanks, Christopher. I'm sorry I didn't have any questions, but
No
I enjoyed the presentation. Sorry.
Yeah, no, that's great. Thank you very much, and hopefully the information is helpful.
It was for sure, and the presentation was very well thought. I like the way that you managed to show the concepts and also show the exercise. So thanks a lot.
Yeah, I appreciate that.
It was very concise and helpful.
Thank you. Thank you.
Thanks.
Right.
Have a great
Chris, can you hear me?
Yes. Yes, I can hear you.
Great job. on a difficult topic with lots of moving parts.
Yeah.
Yeah. So I have never done that. I don't come at this from that point of view. I gave a talk on value creation, which is our focus, and I just wrote you a question about how you keep everyone aligned on the customer while you're doing this. You've got a lot of moving parts, and you're dealing with a lot of issues. Obviously, a huge piece on the human side as well, which was really good. But how do you do that? How do you think about that part of it?
Yeah. So we do have like a separate marketing department, and they do have somebody that fills kind of the traditional product owner role in our environment. And so I'd say that in that space we have a lot of different things. So our teams will be happy to perhaps argue with the product owner if if they think something is wrong. And I think the reason that they can do that is because we have all the feedback information coming, we're being broadcast, regardless of person, right? So in many organizations, you'll have situations where product owners are the only ones seeing any feedback, if at all, and then they're filtering everything down and then still giving the team what they need. And so we have product owners, but we also have transparency to everybody involved. And so I think the combination of the two really leads to, we have direction, but we also have the ability to challenge with radical candor, I guess is a good way to put it. This idea of challenge directly, but care personally about the person. And so the product owner defines what the next item goes on in the Kanban. And then from there, the team will pick it up, work on it. And then, even yesterday, I think we had a team where the product owner came in and said, we need to completely change direction based on what we're going on now because of something I learned yesterday. And so we just said, okay, let's just start with a clean Kanban. So we archived the old Kanban, started a new one, and added new tasks on it. And we just ignored everything, the hundreds of cards that were there before. And it's kind of a testament to just saying like, hey, the team is resilient to this unknown change that just came out of nowhere. And a lot of those things can only be tested, kind of in the middle of the work, because you might say that you're prepared, but you might not necessarily be, right? So,
It's this conference is fascinating to me. I used to run a company called SRI International, Stanford Research Institute. So as you can imagine, we had some pretty big software projects. High definition television, we set the standard for that. We did Siri, that's now on the iPhone. And HDTV was a perfect example of Agile. We didn't know, nobody was talking about Agile when we did that. But it was a perfect example where we had to show up on a deadline. If we didn't, it was a competition. So you either showed up or you were out. And of course, our customer, I'm sure you really can relate to this, our customer waited until the very last minute to commit to this, because ultimately it was a multi-billion-dollar commitment. If you're going to go after this, it's a big play, because you're setting the world standard for what it will be. So our customer waited to the last minute. So all the kind of people problems you mentioned all came up. Of course, the team was going crazy. But we had a guy like you, our program manager, who was just brilliant. And I wrote a book about this, but what we did called Innovation.
Nice.
And he's the hero of one of the chapters, him and a technician. Not the technical guys, they did their part, but the two heroes. And what the program manager did is basic Agile. He basically broke the project down into pieces, talked to everybody, didn't force anybody to do a thing they didn't commit to, put together the plan and put it on a board in a big room with everybody in the room, and everybody came in angry and they were about to revolt. And he stood up after I stood up, and our technical guy stood up and said a few words. he stood up and said, our plan is on the board. And this plan goes from one end of the auditorium to the other. It's a big, we're talking about probably total of 200 people on this project.
Nice.
And it's all broken down into these little pieces. And he says, by the way, when I put this together, I didn't take any time away from anybody. In fact, I gave Chris, you have a really hard part, so I gave you 2 extra weeks to do your part.
Yeah.
And then he did that through the whole thing.
Nice.
And he said, when you see this, we're going to be late by 1 week, but we have a strategy to make it up. And basically, that was Agile, which would be we'd be constantly reconfiguring the teams as we went along, depending on what was going on, repurposing the team members. So many of the things you talked about today, we obviously had to build into the program.
Nice.
Anyway, it comes to the end, and we're not ready. But fortunately, none of the other teams are ready, so we get an extra week. And that week, our system was not working. And with digital, of course, you stick stuff in.
Yeah.
And if there's one mistake, it doesn't come out. You've probably been there and done this, right?
Yeah.
So where is the mistake? And we had a technician who literally was working almost 20 hours a day. He was sleeping by the equipment. He took every switch apart. And finally, he found one switch that had been put together upside down. He fixed that. The system worked perfectly.
Nice.
We went to the competition and we won.
Nice.
Now, what are people like that worth, right?
Yeah.
Everything. So people, the kind of experience you've had and the ability to manage those kind of teams is, I don't think it gets enough credit. And imagine what's going on with Musk's teams right now.
Yeah.
Yeah.
Okay. I have no idea, but it might be interesting.
But you have a good idea. I think you have a really good idea. Anyway, I just wanted to thank you. I thought you did a great job today.
Thank you. Yeah, appreciate that. It's nice to have the opportunities to be able to work with people that both kind of tolerate the experimentation, but also encourage it. And so it's very I have a great team I work with, and a lot of I've been able to validate a lot of my ideas and hypotheses and things like that. So
experimentation is the way to do it, the only way to do it, because what we do is human and it's experiential. So you can't get around it. I used to work for RCA, and they used to give me tens of millions of dollars to spend every year.
Yeah.
I was good at that. I was good at spending money.
Good skill to have.
I had high definition television. I had what would have been the first internet company in the world with Citicorp and 9X as my partners. And then one day GE bought us, and then we were spun out to SRI. And so instead of giving me tens of millions of dollars every year, I had to go earn tens of millions of dollars every year.
Yeah.
And what we realized is we didn't have a clue, because they don't, in big companies, as you know, they don't teach you these things.
Yeah.
So my best friend came in and said, we have to learn.
Yep.
It's like everything else, we just have to learn. So my team got together from 5 o'clock until 9 o'clock every other Monday night, and we all stood up, gave our value proposition, and said something we learned. And we tried every book you can imagine at the time. None of them worked. Not a single one worked. All the stuff that's written about didn't work.
Yeah.
And bit by bit, we put together a methodology. It's very simple. You'd recognize every bit of it. But as you know, most people don't do that stuff, the right stuff. And when I became CEO of SRI, it had been failing for 20 years. We grew it 3.5 times, and we created one multi-billion-dollar business after another. We created Nuance Communication, the leading speech company, Siri, on the iPhone, Intuitive Surgical, that's a $60 billion company, HDTV, satellite broadcasting. These are the same people who've been failing for 20 years. Yeah. And all we did was give them a different way of working that's very much in alignment with what you've been talking about and the other people at the conference. Kind of amazing, huh?
That's really cool, and I love hearing agile success stories or lean success stories
Yeah.
for sure. So,
Well, if you do, it's all about learning, right? That's what
yeah,
your talk was about, is about
yeah,
learning. How do you learn these things? And the whole idea is if you mess up some of these things, you're going to get in trouble.
yeah,
So how do you monitor them? How do you do experiments about them? Um, it won't be perfect. A lot of things are going to fail, but so what, right?
yeah. Learning is your competitive advantage, and you have to maximize the amount of learning you can do.
I told when I went to the board. The board always wanted to know whether we're going to be successful, and I kept on saying, yeah, we're going to get. We may be in debt. The buildings may be falling down. Everybody might hate each other, but if we can get people to work this way, we'll turn the place around.
Yeah,
And it's all based on learning, and that became our competitive advantage. We beat IBM and all the other big companies by about 5 years with Siri. And we were 2,500 people, so we're not a small company, but
yeah.
we weren't IBM, right?
Mm-hmm.
Why is it that we beat them by 5 years? Because they don't collaborate. They don't work
Yeah.
together. They don't. They say they do. They say they're agile, but they really aren't, as you know.
Sure. Yeah.
But we were. We actually walked the talk, and everybody in the company had to stand up. Another basic principle. We all had to stand up every 2 to 4 weeks and give the value proposition for what we were working on.
Yeah.
Everybody.
Cool.
And you only had 3 minutes. So I had to be quick. You get feedback, but it created radical transparency in the organization. And through that radical transparency, we actually could put teams together to solve some of the biggest, most important problems in the world. Because again,
that's awesome.
It was about learning. It keeps,
Yeah.
So let me ask you this. So how long have you been part of the Agile community here?
How long have I been part of it? Probably so kind of in the conference circuit for about 8 years or so.
Oh, so you're almost at the beginning of this, right?
Yeah. So I've been writing software for, I don't know, 15 years or so.
Yeah.
15 to 20 years at this point.
Well, Steve Denning is a good friend of mine. So
Yeah.
you know Steve, I'm sure. Yeah. So that's how I got invited here. So so Agile is a funny thing because it includes all kinds of different disciplines, different approaches, what have you. If you were to tell me what you think the 3 guiding principles of Agile are, what would they be?
3 guiding, well, there's the Agile Manifesto, but that's just the 4 and the things like that. But I think to me, I would look closer to lean, right? So like ultimately what I look for is things like being lean, treating each other with respect, kindness, consideration, respect, and psychological safety. And something along the lines of like delivering value, learning quickly, delivering value, that sort of stuff. So like, learning, lean, and psychological safety, I think would be the 3 key aspects. Because I think
it's funny. Yeah, I like that. I was thinking this morning, and what would my 3 principles be? It would be customer value, number 1. Number 2 is learning. And number 3 is respecting human fundamental principles. Those 3 things.
It's fantastic.
And if you put the focus on the customer and the learning, you almost always end up in a good place, right?
Yeah.
And that's what your talk was about. It was about another piece of this puzzle, but how do we learn fast enough to actually be able to improve what's going on, to deliver more value?
And I've seen too many organizations where people treated each other poorly and things like that, right? And so
doesn't work.
Yeah, it doesn't. Yeah, it just slows you down, and so that's been a big part of it for me. And I think that in my talk just now, a lot of it based around rotating things around and things along those lines. There's a side effect to that, and that's that people develop empathy for each other, which
exactly right.
I think is an uncommon thing in our industry. So
Well, again, it depends on who's running the project and if the managers behave. We've done workshops with over 500 teams. Some of the biggest, I can't mention them, but you'd recognize almost, a whole list of them. And when the managers behave and are inclusive, it's amazing what happens. In the few cases where the managers sat there and criticized their people, it just comes to a halt. It just stops. Yeah. In the one company, so imagine a top 10 company in the world. They're all PhDs from Harvard, MIT, Caltech. These people are not dumb, right? They're really serious professionals. And we're doing this workshop, and they bring in what they say are their 6 major initiatives. After the first morning, it's clear that nothing they're doing has any value for anybody. Nothing. Zero. Yeah. And the manager is not participating. The manager's in the back of the room criticizing his people the whole time. Yeah. And I remember I walked out of that workshop after 2 days being depressed because of those people, right? It's like, you've got all the trappings of success, but you're just wasting your life, and you're working for a jerk.
Yeah.
No.
It happens time to time.
No, that was one of the big things that happened at SRI because the way people treated each other. And just a little twist we put. So we called them value creation forums. So as I said, every 2 to 4 weeks, we'd all come in. There'd be 5 or 6 teams there. You give your value proposition from 3 to 5 minutes, and then you get feedback. What was good, what could be improved, eyes of the customer, basic stuff, And the speaker had to be quiet to get the feedback. They're quiet because you want them to listen. You don't want them to argue because arguing creates a bad feeling. One of the things you brought up today is, how do you navigate these problems that come up? And the presentations are always so terrible. It doesn't matter. Why are you arguing about it? It's just nobody can answer the 4 questions we ask. And so the meetings were unrelentingly positive. You could only give helpful suggestions about how to get better. And the thing about it is, if it didn't make sense, it went away by itself. If it couldn't be debugged and de-risked by itself, you didn't have to tell them, it's a terrible idea. It went away. And that was one of the magical things that all of a sudden, and by the way, this is what we find when we do workshops with these big companies. Typically less than a quarter of what they're working on has any value for anybody. And of course, we never tell them that. We just give them a framework. And at the end of the workshop, they go, it's amazing. Because we couldn't tell them that, their baby is ugly, right? That doesn't work.
Yeah. Can't do that.
Anyway.
Cool.
Well, listen, Chris, great job today. Great to talk with you.
Yeah. It's very nice meeting you. And, it was an interesting conversation. So, and I appreciate the feedback. Yeah.
Thank you. Good job.
Right. Have a great one. Bye, everyone. Thank you.
Bye.
See you, Kurt. Thank you.